Assalamualaikum, my name is Iqbal bin Ahmad Hamzah. I'm with number CN240175. And for the introduction, C++ was chosen due to its speed, efficiency, strong typing, and suitable for high performance and reliable application. Also, it provides a clear program structures, support collaborability, and it's portable across multiple platforms. So the system was developed in using Kotlin. The project is titled Cybersecurity Asset Management System. It is designed to identify, monitor, and manage both physical and cyber assets within a premise. Feature- Features include asset restoration to prevent unauthorized access, status monitoring, which is active and inactive maintenance, and report generation. The reporting function summarizes asset status and risk level to help identify potential threats. So the project provides hands-on experience in developing a functional C++ system. Lastly, it demonstrates practical application of programming concepts for real-world cybersecurity needs. And next slide for the problem statement, the number of physical and cyber assets is increasing, making asset management more complex. Second, many organizations still rely on manual asset tracking method. For the third, manual tracking often result in incomplete and outdated asset record. Fourth, without a centralized system, updating asset status and assessing risk level become time-consuming. And lastly, manual process can cause human error, slow reporting, and delay maintenance. And next, for the description of project. First, the cybersecurity asset management system is console-based C++ application designed to manage physical and cyber assets. It uses a menu-driven interface to register assets, update status, and generate report. For the third, asset data is stored in a local file to ensure the data persistence. And last, each asset has a unique ID, asset type, status, and critically level for basic risk assessment and better decision making.
Alright, so next I will presenting for our project aim. This project develop a cybersecurity asset management system using C++. The system organize and manage physical and cyber asset in a centralized manner. Next, it enable asset tracking, status monitoring, and basic risk assessment. Next, the system improve asset visibility, data accuracy, and cybersecurity governance. The last one is a user-friendly and reliable design support informed decision making and better asset protection. So next, I will explain about our objective for this project. First, to design and develop a C++ based cybersecurity asset management system for the structure registration and management of organizational assets. Second, to implement asset monitoring features that enable efficient updating, viewing, and management of asset status, location, and ownership details. Third, to incorporate a basic cybersecurity risk assessment function to help identify potential security risks associated with each asset. Lastly, to develop a user-friendly and reliable system with a clear, well-structured interface suitable for organizational use. So next, I will explain about our flowchart for this project. This flowchart shows the overall workflow of the cybersecurity asset management system. The system starts by displaying the main menu to user through a command line interface. From the main menu, the user can choose options such as registration a new asset, viewing the registered asset list, or exiting the system. When the user select the asset registration option, the system prompt the user to enter asset details such as asset name, asset type, status, location, and critically level. After the user enters the required information, the system validates the input and stores the asset data into a local file to ensure data persistence. Once the asset is successfully saved, the system updates the registered asset list and returns the user to main menu. If the user chooses to view the registered asset, the system retrieves all stored asset data from the file and display it in a structured and organized format. This allows the user to easily monitor asset status and risk information. The process continues until the user selects the exit option, which safely terminates the program. Overall, the flowchart illustrates a clear and systematic process for managing assets efficiently within the system. So this is our 16 registered asset, 8 asset for physical and 8 asset for cyber. So for the physical asset, we have desktop PC, laptop, server, router, switch, printer, CCTV camera, and access point. For the cyber asset, we have operating system, database system, asset management software, user account admin, user account staff, firewall configuration, backup data, and antivirus software.
So now I will continue on interface description. The interface of the cybersecurity asset management system is designed using a text-based command lines interface. To ensure simplicity and ease of use, it presents information in a clear and organized format with headings, separators, and aligned text to improve readability. The interface displays register asset detail and system summaries in structured sections, allowing user to view asset status and risk information efficiently. User interaction is performed through menu selection and data input prompts, making the system suitable for monitoring, reporting, and managing assets in an organized and user-friendly manner. So next, I will continue on interface type. Command line interface, that's CLI, also known as a text-based interface to allow user to interact with the system. User provide input by typing commands or selecting menu option, and the system display output in a clear and structured text format. This type of interface is simple, lightweight, and efficient, making it suitable for system administrator and technical user. The CLI interface also requires minimal system resource and enable fast access to asset information without the need for complex graphical components. So, the third one is interface layer. The interface is divided into two main sections. So, the first one is register asset list, and the second one is asset summary. So, I will discuss for the first one. The registered asset list display detailed information for each asset. Show asset ID, name, type, status, its level, and location. Help user monitor and track individual asset easily. Allow quick identification of asset condition and risk. The next one is asset summary. Provide an overview of all assets. Display total asset, active asset, inactive asset, and asset under maintenance. Show the number of low risk and high risk. Help user quickly access the system overall status and security level. So the next part is user interaction. The user interact with the cybersecurity asset management system through a menu-driven command line interface. Users select option by entering numeric command to registration. The system prompt the user to input asset details such as name, type, status, and quantity. The system then processes the input, store the data in a file, and display the updated asset list and summary in a structured table format. This interaction method is simple, efficient, and suitable for monitoring and managing assets without requiring advanced technical skill.
Now I will explain about advantage of interface. Firstly, interface is easy of use. A well-designed interface make a simple make system easier to understand and operate, especially for the new user. For the second one is efficiency and productivity. Interface user can complete tasks faster because functions are organized and easily accessible. And for the third one is interface can improve communication. Interface allow different system or component to exchange data accurately and efficiently. Let's move forward to disadvantages of interface. They have three disadvantages. For the first one is cost, and then performance overhead, and then the compatibility issues. For the cost, developing and maintaining interface can increase overall system cost. And then for the performance overhead, system performance interface can be slowed down if the system is too complex. For the compatibility issues, different interface standards may not work well together. So lastly, for the conclusion, this cybersecurity asset management system successfully applies C++ programming to solve real-world asset tracking and cybersecurity needs. It enables structured registration, monitoring, and risk assessment of physical and cyber assets through a console-based interface with persistent file storage. The project provides hands-on experience in software design, logic implementation, and teamwork, reinforcing core programming skills using Block IDE. While functional and reliable, future improvements could include a GUI, advanced reporting, and user authentication for broader organizational use. This project demonstrates how C++ can be used to build practice scalable systems for cybersecurity and asset management, meeting both academic and real-world objectives. So that's all from us. Thank you.